Hello and welcome to another video. This time we're going to be looking at adding an LCD display to our Agon computer. Looking at this LCD display, you're probably thinking, crikey, that's 40 years old. But this one's different. It's got an i2c backpack. And if you look closely, you'll also see that it's using the same chip that we used for the 8-bit I/O port, the PCF8574. But don't let that fool you. Coding for this display is not as easy. On the back you've got the usual I2c pins, there's a variable resistor to control the LCD contrast, and some solder pads to change the bus ID. I've found that this module actually wants to work on 5 volts rather than 3.3, and the EZ80 pins should be tolerant for that. There are similar modules available which use a UART serial connection, but they're a lot more expensive. When the unit's plugged in, the backlight automatically comes on. But what I'll do is I'll run the code first and then we'll step through some of it. So what we're doing here is that we've initialized the device, we've loaded up some custom characters and printed some information to the screen. This module has 2 lines of 16 characters. So we've printed 0, 1, 2, 3, a space, and then a custom box character. On the second line, we've written a string, Agon Light 2. And in the top right hand corner, a little custom character. So how do we achieve that? But the code needed to do this on this module is quite complicated. So really I'll just step through some of the commands that I've created, and then you can go through the detail at your own pace. There's an LCD init command, and this is called once at the beginning. It prepares the LCD screen. We've got an LCD send command, and this is for sending commands to the LCD. And there's also an LCD send data, and this is for sending data to the LCD. That is, the characters we're going to print on the screen. I've created a routine to tab to a particular position on the display. There's a routine to print a string, so rather than having to do each character one at a time, you can just give it a string to print. And finally, a routine to generate a custom user-defined graphic character. If we quickly step through what happens in this program, you can see how we generated that display. At the start, there are a few macros defined, as well as some constants. But here's where we really start. First, we open up the i2c bus, and then we call the LCD init routine. We then create a user-defined character, and I've called it alien, and a second one, box. We then clear the screen by loading A with the command to clear, and then sending that command. And then I'm loading A with the command to go to line 1 and sending that command. And at this point the display is set up ready to print things on the screen. So as we've seen, we printed 0, 1, 2, 3 and a space. For each of these basic characters we just load A with the character we want to send and then do LCD send data. Next we send a box. And then we send a command to go to line 2. So we load A with the command to line 2 and send that command. So that's completed the first line, 0, 1, 2, 3, and a box. And then we jump to line 2. So as we've gone to line 2, we want to print a message. And so I defined HL with the address of the message to print and call the print string routine. We then load B and C with the line and column addresses. So B is which line down, C is which column across, and then call the LCD tab 2 routine. Then we load A with the character for the alien and send that data. So we then end up with all the characters on the screen that you can see. If we take a quick look at some of those routines, the LCD print string routine is quite simple. We start with HL containing the address of the string, and we terminate with an FF in hexadecimal. So we load A with the first character and see if it's FF, and if it is, then return. Otherwise, A contains the character that we send the data. We then increase HL and go round the loop again and keep going until we get to an FF character. In order to create a user-defined character, we need to know two things. One, where is it to be stored? And two, what is the data which makes it up? If we look at the data for our alien and our box characters that we've defined, you can see here that the first byte contains the memory address to which it's going to be stored. And then we've got the 8 bytes of the actual graphics. And the same for the next one. HL will contain a pointer to the data, and the first byte will be the memory address of where it's going to be stored. So we then send that command. We then load B with 8 so that we can go around in a loop 8 times, grabbing each of the next consecutive bytes and sending them out as data. If we look at the LCD init routine, this does a number of things. Firstly, it sets up the display to work in what's known as 4-bit mode. It then clears the screen ready for it to be used. So with this simple set of functions, you can pretty much print anything you like anywhere on the display. Maybe you've got the need for an LCD attached to your Agon computer. If so, this is quite a straightforward way of adding one.